All right, everybody, welcome to this slightly short notice pop-up office hours session motivated by the modest wildfire outbreak in California over the weekend. Just a reminder that this channel is partially sponsored by Reask, a company that is rethinking Earth system risk in a warming climate. So today's session, I wanted to focus mainly on the current wildfires in California, talk a little bit about what we are and aren't seeing right now, because I think there's a lot of fear and anxiety surrounding wildfire in California following the 2010s and 2020. I have some good news and some bad news for those folks, but the short-term news is maybe a little bit better than you're expecting. And then I want to talk a little bit more. I've been emphasizing in recent sessions sort of how there are predictable elements to fire season and unpredictable elements to fire season, and how the predictable elements are telling us that conditions later this summer could be quite different from these early season milder conditions, and we could in fact see a very active finish to fire season 2024, but that we aren't there yet. Despite the current activity level, this is not yet indicative of really active conditions. We'll talk all about that today, a little bit about the whole North American perspective right now, because there is a potentially historic heat wave unfolding across portions of the eastern U.S., all the way from about Chicago, so even portions of the Midwest all the way east to New England, and parts of Southeast Canada, where temperatures during this heat wave, it'll be a very prolonged heat wave for June, and some places may set new June temperature records under one of the strongest ridges of high pressure ever observed in the eastern U.S. later this week. So there is a lot going on right now, California and beyond. To talk about all of that today. So right now what we have from over the weekend is a number of wildfires broke out. Almost all of them, or at least all the ones that had any momentum to them and weren't pretty quickly extinguished, were ignited in grass or relatively brushy ecosystems. So grass brush mix, kind of the classic setting for early season fires in California, because grasses are the first things that dry out during fire season, particularly in Southern California, and particularly in the more sun-exposed portions of Northern California. So less so on the north-facing slopes, more so on the south-facing slopes, as you'd expect. Those grasses are starting to dry out and cure, so those dry brown grasses are starting to become rather flammable. And this year, as we've been talking about, as the result of 2 consecutive wet winters, there is a lot of additional growth particularly of grass, but also to a lesser extent of that heavier brush too. And so because there is a particularly high fuel loading, as you would say in the biz, that is potentially offering more biomass to burn in whatever fires do occur. Now, right now, that biomass is not yet unusually dry, so we do not have unusually dry fuel conditions across most of California right now. It is clearly getting drier because we are now seeing these fires, but we're not seeing these fires behave as extremely as we would later in the season when the vegetation is even drier, or during, say, a severe drought like the ones we had in the 2010s, where these fires would routinely do non-routine things because of just how exceptionally tinder dry, record-breaking vegetation dryness. We do not have that right now. What we're not really seeing are very active fires in forested settings, because those settings are still relatively moist. We are still in mid-June, so even in a typical year, mid-June would be nowhere near peak seasonal dryness, but that's especially true this year in the mountains, partly because we've now had 2 consecutive years of near to above average snowpack in most places, but in general, 2 consecutive years of good moisture and not extremely hot temperatures, at least up to this point. That is now starting to change. We've actually had quite a hot June thus far. It looks like, for the most part, that's going to continue despite the current cool down. Right now, we're having a bit of a cool down in California, especially across the interior, but the trade-off is that now it's very dry and windy. So it is cooler, but the dry and windy conditions are fueling some grass fires and brush fires, some of which have caused some significant problems. But it will warm back up later this month to above average temperatures once again, and that is actually expected to be the theme for the rest of the summer into the autumn, where well above average temperatures and below average precipitation through the autumn across much of the west, especially the interior west, but also including most of California, especially away from the immediate coast, which is where we're seeing these fires now and where fire risk later this season will probably be maximized. So right now, as I mentioned yesterday, there were a number of fires that reached at least several hundred acres, but a number of them are already largely under control or extinguished, not really causing any problems at this point. There were some structures lost in the low single digits, it sounds like right now, in some of these fires. So they were fast moving in the initial hours, and sometimes even a grass fire can cause structure losses if it's fast moving and if there's not meaningful defensible space. And sometimes even then, if it's really windy, you tend to get those embers that can really it's really, the process is called ember attack, and it's when you have thousands or even millions, in the case of a big fire, embers just being generated by a fire and constantly buffeting structures or vegetation downwind of a fire break or something. It makes it very easy for fires to spot across roads and rivers and control lines. And also, it means that even if you have defensible space in some cases, if it's very windy and there's a lot of embers, that may not be enough. This is one of the reasons, by the way, why fire protection experts now really suggest home hardening or structure hardening, including things like covering your vents with ember-resistant coverings, because a lot of times the exterior of homes is actually fairly fire-resistant, but then under constant ember attack, those embers will make their way inside homes, into attics, through vents, and then start fires from the inside out. That's actually a very common way for structures, especially residential structures, to burn during wildfires. Is the exterior might actually be fairly flame resistant, but then those embers get inside, and the interior of structures is often much less resistant to ignition than the exterior. So that's your advice for the day: ember-resistant vents for wind-driven fire protection. Anyway, what we've seen is that a lot of these fires have not, beyond their first day, gone on to do all that much, because we are still relatively early season. Firefighting resource availability is relatively high, although it's starting to get drawn down a little bit because there is now an increasing amount of fire activity, and the vegetation isn't as dry as it will be at peak season. That said, there are two fires that have been more problematic than the others, one of which is much larger than the others. I'll start in Southern California. I keep getting these mixed up because the fires actually have similar names. So I believe in Southern California, this is the Post Fire off of I-5 near Gorman. It's caused some closures of Interstate 5. It may have burned some structures, I don't know. There's not a lot of residential structures in the area, so I don't think that's the great concern. This is a fire that started near the freeway. It looks like it actually started, as often is the case, as a structure fire at an auto shop right off the interstate. So folks say, how do you get human-caused fires? Is it always carelessness? Well, I don't know what happened at the auto shop, but you do sometimes get structure fires. Generally speaking, those are not things that people start on purpose. And it moved under windy conditions into the grass and then into the brush, and then it was off to the races once it started burning up slope. Anyway, this fire is now well above 10,000 acres. I don't know what the morning update is, but it's probably getting closer to 20,000. So it's a pretty big fire, not enormous by California standards, but also no longer small, no longer a small grass fire by the roadside. It has been primarily burning in brush and grass, but it looks like because of its current trajectory toward the south, so burning from north to south, it does look like it's going to head into heavier vegetation and more rugged terrain as it gets into the mountains. And there is some, it's heavier brush and then maybe some mixed forest eventually, depending. So it is going to move into heavier fuel models, heavier fuel types, and it on the southern flank is probably going to become a little bit harder to deal with, especially given that there are red flag or near red flag conditions, at least for today and possibly one or two other times this week. So there are pretty adverse fire conditions, not extreme, but elevated enough that given that there are multiple fires ongoing, that's going to be a bit of a challenge. So this fire will be in the picture for at least a few more days. We'll see how it goes. No, I don't think there's any major residential areas immediately at threat. There are some evacuation orders, although it's mostly pretty rural areas with some scattered structures out there. So this is not this is a pretty typical Southern California fire in the sense that it's burning a lot of brush, and it's an earlier season fire, so it's not really a forest fire at this point. The forests, the higher elevation forests in Southern California remain pretty moist. It was exceptionally wet this past winter, particularly in Southern California, even more so than Northern California. So there is residual moisture up there. So the conditions at lower elevations are not necessarily representative of what it's like up in the mountains, up in the trees. So that's helpful at this stage. Same thing is true up in the Sierra Nevada, where we're not really seeing any meaningful wildfire activity. There have been a few starts and they've pretty much sputtered out. So what we're still seeing is some prescribed fire activity up at higher elevations, and that is because the conditions there are not the same as we have at lower elevations right now, which are becoming much drier, especially in the grassier systems. It is not very dry up at elevation, and the live fuel moisture is not low. In fact, it's above average in a lot of places, still because of all that additional moisture we got this winter. So this is not like a peak season fire situation. This is more sort of I guess you could call it episodic or wind-driven little mini outbreak of fires, because they're primarily being driven by the fact that it is dry and windy in the short term, and that when that happens, the grass that has cured can dry out quickly and become rather flammable. That can help carry flames into other types of vegetation that aren't quite as dry, and they will burn under these conditions, but not as intensely as they would later in the season when things are drier. So the other fire of interest, really, that's likely to be with us for at least a couple more days in the news is the Point Fire. That's up in Sonoma County, near Lake Sonoma, sort of northwest, I believe, of Healdsburg. So it's west of the Highway 101 corridor. It's about, I think it's around 1,000 acres. So it did get relatively big pretty fast. It's burning in mixed vegetation types, so there is a mix of grass, brush, and trees. There's some oak woodland and some other types of vegetation up there, so that's a little bit more mixed. Although I do think that the grass and lighter brush components driving a lot of the spread, because that's what's driest right now. Some pretty active behavior on that fire yesterday. It put up quite a plume on the cameras. Pretty wind driven. There were wind gusts as high as 30 or 40 miles an hour essentially from the north to south, and that's largely the direction the fire went in. So again, a pretty wind driven event. Unfortunately, it does sound like there was some small scale structure loss. There's evacuation orders for some roads, some roads with structures and houses on them. There's some vineyards in the area. Vineyards themselves are probably fine in this setting, but some of the houses up in the wooded and brushy streets leading off of the valley roads, it sounds like there were some issues. I think that this is probably, despite the fact that there are borderline red flag conditions today in the region, there's red flag warnings in effect for much of the Northern California Central Valley and the foothills. I don't believe there's technically one in effect for this fire region, but the reality is the conditions will probably be close to red flag, so it will be a tough firefighting day. But again, this is early season. There's pretty good availability of firefighting resources. The non-grass, non-brush, especially the live fuel component of the heavier vegetation, is not particularly dry. So this is a different fire than if we had the same fire, say, in September or October. The winds are not as strong as they can be in September or October, and perhaps even more importantly, the vegetation is not as dry as it could be or will be later this season. again, I think that what we're seeing is that we have entered fire season unambiguously, especially at lower elevations. I still think we're not quite there yet at higher elevations, but we're there at lower elevations, and we will see increased grass and brush fire activity during hot, dry, and windy periods. Right now it's not super hot, but it is dry and windy, so we check enough of those boxes to cause some problems. And there may be other problematic grass and brush fires in both northern and southern California today or tomorrow as these dry, windy conditions continue. So it's the classic case where it's a good idea to be careful with any sparks that you might start. Again, the notion that all grass fires are bad fires is I think, it's increasingly recognized as misguided. Some of these fires are going to have benefits because they're doing some of the prescribed burning that we weren't able to achieve through voluntary measures. So long as they don't burn structures, they can actually have net benefits. The challenge is you don't necessarily want to do that under very dry and windy conditions like we have today, so it would be better not to have those ignitions on days like today because sometimes those fires can get out of control pretty quickly when it's this windy. That is, by the way, one reason why, in general, prescribed fires tend not to be done under very windy, very dry conditions. There is sort of this Goldilocks range of conditions where prescribed fire is usually conducted, where it's not too wet, because then you don't accomplish your benefits very easily. It's difficult to get sufficient combustion, or you get a lot of smoldering combustion, and that generates a lot of smoke that you don't want and doesn't really burn much of the underbrush that you want to get rid of or thin. But if it's too hot and dry and windy, you also don't want to do it because the risk of prescribed fire escapes becomes higher. And so generally there's that Goldilocks window where it's dry enough but not too dry, and where it's not completely still. There's a little bit of a breeze, but not too much of a breeze, since you want to ventilate the smoke so people don't it doesn't get trapped in the valleys, people don't breathe it too much, but you also don't want it to be too windy such that the risk goes up. So that is usually, when you talk about controlled burning, prescribed fire, there's this range of environmental conditions in which generally it is conducted. The range is not the same everywhere. It depends both on the goals of a particular prescribed burn and the type of vegetation you're burning in, and things like local regulations sometimes play into it. So it's not one size fits all. It's a dynamic and not fully objective criteria. Sometimes burn bosses will pull the plug if there are some conditions that are a little bit untoward. But generally speaking, we've seen a fair bit of prescribed burning in California so far this year, because conditions have been pretty favorable for really between early spring and even now at present in some of the places that are not experiencing strong winds today. The conditions are actually quite favorable for prescribed fire above the wind layer. It's not windy everywhere. So your mileage may vary. The local conditions matter a lot, and there's always a pretty complex calculus that goes into the red light, green light on actually implementing these burns. So right now we've really got two fires of interest. I actually just checked the satellite imagery about 5 minutes before starting this session. I was going to show it live, and honestly, there's not much to show right now. Yesterday there were two pronounced smoke plumes coming from each of these fires: the Post fire in Southern California and the Point fire in Sonoma County. Right now, there is no meaningful smoke plume to show, no hot pixels on satellite, which means that, which is more consistent with early season fire behaviors. Both of these fires laid down significantly overnight. They became less active. They did not extinguish themselves, of course. They are still burning, but the intensity was greatly reduced, and the smoke emissions are also greatly reduced for the moment. I would expect both of these to pop up and become more active later today, because there is red flag or borderline red flag conditions going to occur later this afternoon. But in general, that is a relatively good sign that we are still in the early season. There are windows in which these fires really calm down at night. Another difference from what we increasingly see with a warming climate, particularly late season, when the temperatures aren't getting as cool as night, or the relative humidity isn't coming up as much at night, and when that vegetation just remains really dry 24 hours a day. We're not there yet, and it's showing because these fires are not behaving in the really extreme way that we saw a lot of wildfires do in the 2010s, when both of those things were true pretty much throughout the year. Now, I think this is the key, which is that you notice that I'm sort of being cagey about the timing and saying not yet, not yet. And that's because this is a season where I do expect to see that transition back towards a really active fire regime across much of California and the West. Maybe a little bit less so at very high elevations, but everywhere else, I think we're going to see a greatly increased level of fire activity this year relative to the past couple of years. And so the real question is, are we already seeing this in June? And I think that the answer is a little bit mixed. We're not seeing major fire activity at high elevations in forested ecosystems yet. So there the answer is no, it's still not happening yet. We're not seeing really active fire behavior straight through the night or numerous simultaneous extreme rapidly spreading fires. So I would also say that even at lower elevations, we're not there yet. So I think we're just getting a sense right now that some of the increased fire behavior we're seeing is partly because there's been, as I mentioned, a lot of extra growth of grass and brush. So we're seeing these large, increasingly aggressive fires in these settings where the grass is unusually heavy, heavy grass crop after wet conditions recently, and where it has sufficiently dried out or cured that the dead fuel moisture type metric is probably the more relevant one to be using, and it's reaching levels that under windy conditions are critically dry. So the answer is a little bit mixed. We're seeing signs that there is an unusual amount of grass and brush at this point. And we're seeing indications that it is now reaching the level, at least at lower to middle elevations in California and the West, that things are dry enough to burn pretty readily under windy and low atmospheric humidity conditions. And that's only going to continue to be the case. We're going to see that level of activity expand to higher elevations, to other vegetation types, and the fires that do occur over the next couple months will become increasingly intense under favorable burning conditions, and I do think we'll see a lot of those favorable burning conditions. So once again, emphasizing that my own prediction has been a near to below average start to fire season in California. By start to fire season, I was largely talking about May and June. We're halfway through June. We're starting to see increased activity, but nothing all that out of the ordinary yet. At scale, at least. I think that's going to start to change probably within the next couple of weeks. So I would say probably by July, we're going to see the manifestation of a really active fire season at the lower elevations becoming increasingly clear, and at higher elevations by August. And that, again, as I talked about last time, is because we have the predictable component of fire season, which is largely based on what has already happened to date. We know that it was really wet the last couple of years. There's been a good snowpack, so there's a lot of extra vegetation, but also that it's extra damp to start the season. So that's why the early season is likely to be near to below average activity broadly across California and the West. But we also have a pretty strong prediction this year that later this season, the summer and autumn will become unusually dry and unusually hot, even relative to the recent baseline across much of the West. And because of that, a weak monsoon and a particularly hot summer, along with a combination of perhaps an unusually dry autumn, especially in California where that's really critical, all of that is semi-predictable and also lends us to believe that we'll transition rapidly from a relatively slow season to quite an accelerated season. So unlike recent years that started slow and stayed slow, I would expect this year to start relatively slow as it has transitioned towards a more, I guess you could call it, average season about mid-season, which is sort of where we're getting to now, and finish very strongly and actually end up being dramatically different, dramatically more active than that early season. So that's where we are now. We're not at peak season yet. These are not peak season fires either in scope or behavior or in terms of where they're burning. In many ways, they're classic early season fires since they're primarily burning in grass and brush, although not exclusively. the grass and brush component is what's driving the more rapid spread under wind conditions right now. So that's sort of what I'm seeing. There could be some problems today. There are pretty widespread red flag warnings, not just in California, but across a good chunk of the West today. So northern Arizona, southern Utah could see some pretty aggressive fire starts or spread today if anything ignites. So there could be increased wildfire activity across a good swath of the Southwest over the next few days, and that will potentially set the stage for some fires that will become campaign fires, as they're called, and will burn for weeks or longer into fire season. There are always some fires that burn like that every year in the West. I think we're starting to get into that season across a broader portion of the West with the adverse fire weather conditions this week, plus record heat across the interior West since the beginning of June. Las Vegas and Phoenix, I believe, both have seen their hottest start to the well, if not the calendar year, at least the hottest start to the season and the hottest early season temperatures in June on record. And again, hot temperatures in Phoenix and Las Vegas are nothing to sneeze at. These are exceptionally hot cities. In fact, I believe they're the hottest large cities in North America, and they've experienced the hottest conditions they've ever experienced this early in the season so far this year. So the surrounding mountains, of course, not much fire risk in Phoenix or Las Vegas proper, but outside these regions, these unusually hot temperatures are representative of a relatively rapid start to the season. And I'm trying to decide whether it's actually worth sharing some of these fuel moisture charts right now, and frankly, they're not that dramatic. What they're really telling us is that what we're seeing right now are not exceptional conditions. We've moved away from being unusually moist, so there has been a transition. All of this recent heat and dryness and wind has dried things out. That is very much true, and the rate of drying is pretty rapid. So we may, in the next week or two, transition toward unusually dry vegetation in some settings. But, we were sort of behind the curve because of all that antecedent moisture to begin with. So that is helping us out now, but with the continued expectation of very hot and very dry conditions this summer, more so than usual. Again, I know there's always folks who say, it's summer, it's hot, it's dry. But of course, when I say hot and dry relative to average, it means relative to how hot and dry it would usually be at this time of year. So it is still meaningful to say that, and it does still matter in the context of fire risk. So I think I won't, because there's actually not that much to show. The one thing that is interesting to talk a little bit about is that there will be a major heat wave, as I mentioned, the eastern half of the United States. So it's not just the eastern seaboard. It's really mostly north of the mid-Atlantic, so stretching really from about Chicago to Maine. In some ways, the most anomalous temperatures are actually in Maine, where the state of Maine may actually experience its hottest temperature ever observed during this heat wave. Other states won't be quite so hot in relative terms, but it will still be record-breaking in terms of daily high temperatures and the strength of the atmospheric ridge. Those 500 millibar heights themselves might be record-breaking. And some places also will break records for duration of severe heat, especially for this early in the season. So that duration matters a lot for human health impacts. The longer the heat wave, the harder it is to deal with it, especially if you get those really warm and humid nights, which are so common in the East Coast, that are much less common, mercifully, in most of the West, except during some of those monsoonal surges that you do occasionally get into places like Phoenix or the Imperial Valley of Southern California, where it can actually be quite humid as well as hot at the same time. Not typical for most of the West, but there are some pockets that are exposed to Gulf of California moisture, because of course the Gulf of California is not all that far away from much of the desert Southwest. In fact, the desert goes right all the way up to the shores of the Gulf. There are sandy beaches that become sandy desert if you go north. So the major heat wave in the eastern U.S., the West is getting a bit of a break, although it's dry and breezy. Cooler, but dry and breezy, that's elevating fire risk. It's actually snowing meaningfully in the northern Rockies, so western Montana getting some June snow. Unusual, but far from unheard of. It does sometimes still happen in June. If this were July or August, it might be a bit of a different story, but well, even August, late August, you sometimes get some snows in the Northern Rockies as well. If it were July, this would be quite unusual. But again, it's still mid-June, so this does occasionally happen. And of course, it's not equal and opposite. It's much more anomalously warm in the eastern U.S. right now than it is anomalously cool in the west. So as usual, in a warming climate, as we stair step upward to ever warmer levels, the anomalous warmth almost always wins over the anomalous coolness. It's really hard to get record-breaking cool or cold temperatures these days. Not impossible, but it's quite hard. It seems like it's almost trivially easy to see record warmth on the warm side of those temperature dipoles like we're seeing right now. And what is interesting is that by late June, or by even June 23rd, 24th, and onward into early July, the long-range outlook for the West and California actually looks like we're going to see another episode of pretty significant heat, elevated heat relative to average, so above average temperatures once again by late June and early July for most of the West, including, once again, the interior of California. What's interesting, though, as I mentioned, is that it looks like the eastern U.S. heat wave, it won't be extreme by then, but it might persist, meaning we might have a double-barreled heat wave, which is pretty unusual. Often in North America, when one half of the country is cool, the other half is warm, and vice versa. But by late June, it actually looks like there might be a double-barreled heat wave with pretty major anomalous heat across the west, and then again across the east, with the middle of the country being not even really cool, just sort of right around average for late June. So that'll be a fairly unusual pattern, and may help facilitate some tropical cyclone activity in the Gulf, some really extreme rainfall in Texas following the really extreme rainfall in Florida that is very much related to the fact that the Gulf of Mexico is warmer than it has been in recorded history in many areas. And as usual, in a warming climate, that increased humidity, that increased atmospheric moisture over ocean basins leads to significant increases in the extremity of extreme precipitation. So that water vapor holding capacity of the atmosphere increases by about 7% per degree centigrade of warming, or about 4% per degree Fahrenheit of warming. And what we see is an increase in extreme precipitation that largely mirrors that value, but sometimes exceeds it for certain kinds of very extreme rainfall events. So in other words, at least a 4% per Fahrenheit or 7% per centigrade increase in extreme precipitation. And now that we're living in a world that's 1.3, 1.4 centigrade above the long-term average on a long-term basis, and this year and last year is even warmer than that, more like 1.5 to 1.6 centigrade above the long-term average, all of a sudden a 7% increase per degree starts to sound pretty substantial, because we're already well past that first degree and on our way to that second degree. So that first 7% and then the compounding 7% on top of that 7% starts to get us more like a 10 to 15% increase in some of these extreme precipitation events with the warming levels that we've seen. And all of a sudden, that's not such a small number at all. So no extreme precipitation, just to reiterate, on the horizon for California or the West. At this point, as you would expect, in June, more of a fire weather concern, certainly elevated, but not particularly extreme relative to autumn standards. And I think that's about all I've got for the monologue portion of today. Seeing a nice healthy uptick in the number of viewers today, so glad to see folks are joining. I know people are probably interested in the wildfire conditions. I am going to go through and answer questions, as I always do, coming through live. I'll take a sip of water. And just remind folks to please, if you are so inclined, follow the channel. Or subscribe to updates if you want to know when I have these sessions. I do occasionally, episodically, have live sessions on short notice. Today's was moderately short notice, less than 24 hours, but I did put it up on social media yesterday and schedule the event. Occasionally, during rapidly evolving events, I will have these sessions on very short notice, like 30 minutes or an hour in advance, as conditions warrant, and so I don't usually know when those are going to happen in advance. So let's see here. Take a sip of water and then continue. Fog Machine mentions early in the conversation that the Sacramento Weather Service Office uh, area of responsibility currently has 8 observing sites that qualify for red flag warning conditions, so sufficiently dry and windy. That certainly validates their red flag warning for the Central Valley and the surrounding foothills today. So certainly high fire risk there, especially given that the primary vegetation type there is grass and some brush, and that is the type of vegetation that has reached critical dryness levels in many areas at this point, even though the forests haven't. So the risk will be high there under these kinds of conditions. Mike mentions that air quality is going to drop across SoCal. There have been some air quality issues with these ongoing fires. Yesterday, there was a fair bit of smoke that blew out over the Inland Empire and even made it out into LA County. So there was even kind of a smoky sunset along the beach in Santa Monica. That could continue today as wind shifts. The specific locations affected are going to vary, but airnow.gov is one option. There's a bunch of private sites you can use to find air quality too. So definitely, breathing in wildfire smoke is never a good thing. In fact, there's been some recent research on just how deadly that wildfire smoke can be, and how many Californians it has harmed over the past decade or so is likely in the tens of thousands. So that's just nothing, something to take quite seriously. Up in the Bay Area right now, it doesn't look like that fire, the point fire, is actually generating that much smoke. Although there may be some localized pretty bad smoke up by Healdsburg along the 101 corridor in the valleys, and then to the valleys to the west. So sometimes that smoke will get trapped under an inversion layer. As the wind picks up, I actually think the irony is that will improve the air quality as the smoke mixes out, but it might also increase fire activity, resulting in more smoke emissions. So again, there has been some North Bay smoke impacts from that fire. It's nothing like the 2020 type smoke impacts in terms of intensity or scope, but something to keep an eye on locally, because even small fires can result in quite substantial local air pollution under certain conditions. Haley Smith from the LA Times asks about the good news, bad news framing I used at the beginning regarding the seasonal outlook. Well, I think I covered that pretty well. I know these questions are a bit lagged from when I'm reading them, but I'll just reiterate what I mean. The good news is essentially that it's been wet the last couple of years, especially in Southern California, and we've had a pretty good snowpack across much of the Intermountain West. This is not so true up in the Pacific Northwest and British Columbia, but elsewhere the snowpack has been good. So high mountain elevation areas are starting out in pretty good shape. The snowpack is mostly gone, but the residual moisture is still there in the soil available to plants and trees, which are not particularly dry at this point. And the good news at lower elevations is we were pretty wet also there. And so this fire season start has been pretty slow, honestly. This is not a crazy start to fire season in California by any means at this point. This has been maybe a near average type conditions right now, but even a slower than average start up to this point. That's the good news, though. So the good news is increasingly in the rearview mirror. We're still sort of on the coattails of that good news now, but the situation is going to start to change, and then the bad news becomes a little bit more prevalent. So the good news is we had a really quiet spring. We had a great window for doing some prescribed burns, and that window continues in some limited areas now, but that is going to be fading shortly as these conditions continue to rapidly warm up, dry out, and get windier. And the bad news is that I think that the back half of this season is going to be much more active with a lot more concerning level of wildfire activity in a lot of areas than the first half. We're not quite there yet, but we're getting closer to that transition point, which based on recent conditions, I think will start to happen sometime in July. So in just a few weeks at lower elevations, and probably more like in August at higher elevations. And then it's going to last longer than usual. So I would in particular expect both September and maybe even October and parts of November in some areas to feature very active fire conditions this season. We could get lucky. Could get a really early season storm that drops some aseasonal rain, but I think that likelihood is much lower even than it would usually be this year, and the background likelihood is pretty low to begin with. So I think that this year we're really going to have to watch out for the August through October period. Maybe July on the margins in some spots, and then maybe also November in some places as well. So I think this is going to be particularly intense late season, and that is the bad news. And so whatever the statistics are at the end of June or even at the end of July, don't be misled into interpreting them to mean that the season is going to be mild overall. There's a lot of evidence to suggest that that is not going to be the case, but it's primarily going to be because of what happens from August through October. I would be happy to be wrong about that, but I also think it's important to be honest, and we do have periods of increased risk. And as I've talked about, the last 2 fire seasons in California, I did not say this about them because, frankly, there was a lot of evidence that they were going to be relatively mild. And they were relatively mild, certainly compared to the 2010s in recent years. This year, I think, is not going to be so quiescent. I think that's just the reality. Does not mean necessarily that there will be particular fire disasters, although the odds do go up in years that are very active overall. There still is that unpredictable component to fire season. Do we get a large dry lightning outbreak at some point? I can't tell you that at this point. It could happen, but it also might not happen. Will we have strong offshore wind events at the following major heat waves right around September? Again, I think the heat waves are going to happen, but we don't really have any predictability of those offshore wind events. Maybe we'll get lucky and won't see many this year, or they won't be very strong. Or on the human side, maybe there won't be many ignitions during offshore wind events. Generally speaking, there are almost no natural wildfire ignitions during Santa Ana wind events because really the only natural fire ignitions that you can get are essentially in the West. Except for some very rare exotic causes, it's essentially lightning. And generally, you do not get Santa Ana winds and lightning in the same weather pattern. They're kind of mutually exclusive. So you can get lightning-ignited fires in California, but usually they're going to occur at different times than when you have those Santa Ana winds. So, which is to say, those offshore winds in fall, when you do get an ignition, it's almost always human caused. Now, a lot of folks conflate human caused to mean arson, and so I will reiterate this at every opportunity. The vast majority of human caused fires are not arson. They're not intentional, they're accidental. That does not mean that they're not due to what some folks might call carelessness or stupidity in some cases. That is a very real risk, is that people do things that are mind-bogglingly inappropriate under high-risk conditions, and sometimes that leads to fires. And that still doesn't mean that they were ignited on purpose, but it certainly means they could have been prevented. But then there's another class of human-caused ignitions that are genuinely hard to avoid. They're not intentional, and they're also not even due to gross negligence. They're just matters of, frankly, bad luck. Sometimes you just get unlucky. Sometimes your house burns down and you live near trees or brush, and that spreads to the brush. Sometimes your car breaks down and you pull a little bit too close to the dry grass, and a hot element of the undercarriage of the car ignites a grass fire. Obviously, there are things you can do, reduce the risk of your house catching on fire, try not to pull over under the dry grass. But at some point, you do start to there are so many potential sparks out there that some of them, a lot of the human-caused ones, are harder to avoid than others. Some are trivially easy. If it's hot, dry, and windy, if you got a red flag warning, don't mow the lawn. Especially don't try and cut the grass with power tools, the brush in your yard. It's just, that's an avoidable risk. We still see wildfires that start when people don't adequately extinguish campfires, which is a highly preventable cause. In fact, under certain conditions in certain places, you really just probably shouldn't be having campfires out in the woods at certain times of year in certain regions. So, there are a lot of human causes. Power line fires, that's a human cause, and that's not something that anyone's doing on purpose either. I know PG&E and Southern California Edison and local utilities have tried to do a better job at preventing these ignitions, partly by turning off the power, and we may see some of those public safety power outages, particularly this fall. Also by doing more preventive maintenance, which is perhaps the best solution because it doesn't cause as many negative societal externalities as just sort of universally and in a widespread, prolonged fashion turning off the power, which can cause its own problems, although it probably does prevent some potentially dangerous ignitions. Point being, this is a bit of a tangent, but we don't have an ability to predict how many human-caused ignitions there are going to be, when they're going to occur, and whether they occur during particularly high-risk conditions. There's a lot of human ignitions that occur. In fact, the vast majority of human ignitions sputter out. It's a small grass fire on someone's empty lot or by the side of a freeway, and one or two fire trucks show up, extinguish it. It's a half-acre grass fire, and that's the end of the story. That's usually what happens with human ignitions. The problem is the small fraction of human ignitions that occur in the wrong place at the wrong time under the wrong conditions, and they really take off. And so that is sort of always a major wild card. We see, for example, a huge spike in human-caused ignitions on the 4th of July, and I'm pretty sure everybody can guess why that happens, because of fireworks, which almost everywhere where they start fires, they're illegal fireworks set off by individuals. So these are not those big organized fireworks displays generally that are starting fires. It's the stuff that people shoot off from their backyard or from parks or from roadsides. There's always a spike in ignitions between the 3rd and the 5th of July every single year. It is remarkable to see the data on this. Those are clearly preventable type of fires as well. But, I think that all the predictable elements with respect to fire season are telling us that we're probably, we have a lot of extra grass and brush growth from the past couple of wet years that helped us up to the present, but it might hurt us moving forward because now we've got high fuel loading in grass and brushy ecosystems and potential fire regimes. And looking forward, we have unusually high expectation of unusually hot and dry conditions later this summer into the fall. And that means that looking forward, that also tells us we're likely to see a significant transition from below active to above active fire conditions at some point. I can't pinpoint exactly when it's going to happen, but my guess now is that this is likely to happen in July at lower elevations and in August at upper elevations, meaning we're going to start to see these effects within the next few weeks now. So that's the good and bad news framing. A bit of a tangent, bonus tangent in there as well. Well, Rochelle Ramirez asks CNN that I mentioned that we're likely to see a very active end to fire season 2024, and I've discussed the sort of the proximal reasons for that. But can I talk a little bit more about that, about how either climate change or our transition out of El Nino could influence things? So both of these are important. I'll actually start with the El Nino piece first, because the transition from El Nino, sometimes that can result in hotter, drier mid-latitude summers. So even though La Nina actually results in slightly cooler global temperatures and in the tropics than El Nino, the transition to La Nina, those summers are often pretty hot in the mid-latitudes as some of that residual heat makes it poleward. There are more ridges, more persistent ridges of high pressure over continental zones, often in those transition summers between El Nino and La Nina like we're in now. That slightly increases the likelihood, say, of a poor monsoon. And if we get strong enough La Nina conditions, it might influence the likelihood of a dry and warm autumn in the west. So right now, a good portion of these seasonal outlooks conditioned on that transition. Of course, El Nino and La Nina, that's a natural cycle. That would be happening in some form, whether or not humans had emitted a bunch of greenhouse gases, heat-trapping greenhouse gases into the atmosphere. We may be modifying the El Nino-La Nina cycling somewhat, actually, and this is an active area of research, but we don't fully understand how, and so for the moment we kind of have to assume that El Nino and La Nina remains largely a natural cycle that we're not directly influencing in a way that we can predict with any certainty. But the climate change component comes in because, of course, one of the reasons why this summer is likely to be record-breaking hot in many regions is that's climate change. The environment is hotter than it used to be, and because it is hotter, in dry places and during dry seasons or during droughts, it gets even hotter and drier than it would have otherwise. So folks sometimes say, well, it's always hot and dry in the West in summer. There's always wildfires in the West every year. So how can climate change really affect that? Well, of course, it's true that summer is the hot season in the West, and places in the West tend to get a lot hotter than places in the East, partly because they are drier to begin with. There isn't as much humidity and clouds to temper those really hot surface temperatures. And it is true that almost essentially all of the West it has a long natural history of fires. Then they would have occurred before humans, and they occurred and were cultivated by indigenous peoples of the West. Also, long before we had big cities and subdivisions potentially in harm's way from wildfires. But there is a difference between the kinds of fires that would have occurred under those settings and the kind of fires that we're seeing today. It is really more a qualitative difference in the intensity and the type and the destructiveness of fires rather than the fact that there are fires to begin with, which of course is a natural process. And there's a strong argument to be made that in many ecosystems we don't have enough fire. There's been a deficit of fire in many Western ecosystems because of some of the impositions of modern firefighting and land management practices. But the climate change component comes in because there's really two pieces to this. One is it's hotter. That's the most obvious one. When it's hotter, there's more evaporative demand. The atmosphere is thirstier. It acts like an increasingly gigantic sponge, extracting more and more water from the landscape where and when it's dry. So in wet places, say like the Gulf Coast I mentioned earlier, this actually means it's even moister and you get even more precipitation extremes than you would otherwise because of that thermodynamic capacity of the atmosphere to hold 7% or so more water per degree Celsius of warming or so. But the reverse is also true. If the atmosphere is not saturated, you actually have a 7% increase in the evaporative potential of the atmosphere per degree of warming. And so that giant sponge, it can both hold more water and wring it out if you're in a moist place or at a moist time, which is relevant, say, during California winters. But it can also extract more water more quickly out of the landscape the rest of the time, which is, of course, relevant for the rest of the year, essentially, in California and much of the West. And so by that measure, you're removing water, you're evaporating water from the soil more quickly and from dead and down vegetation more quickly than you used to. And it's also, in many cases, requiring more water from living plants. There's actually a lot of active research on exactly how plants respond to water stresses and increasing CO2 in a warming climate, and we don't fully actually understand, but it does look like on average there's also more evaporation from plants on balance, even though plants tend to, at large scale, close their stomata to limit that water loss as it gets hotter and drier. They have a limited capacity to do that in most cases before they start to die or wilt. And so on balance, it appears that when you have a larger vapor pressure deficit, that there's more water loss from living plants, but there's unambiguously a lot more evaporation from inert objects. So the soil that has water in it, not that the soil probably make the soil scientists angry. Soil is not inert truly, but at least the evaporation from soil is passive. It's generally not through transpiration. From bodies of water, you can directly evaporate water off of a river or lake. I mean, think about Lake Powell, Lake Oroville, lots of evaporation going on off of those big, broad bodies of water that are exposed to sun and wind throughout the dry season. And also from the plants, and also from debris like logs that are on the forest floor. Those are essentially passive, largely passive evaporators. All of that dries out more quickly and more intensively than it used to in a warming climate. So that increases the flammability. It increases the ability of fires to burn at higher temperatures, to spread more quickly, for more spotting to occur. And when you get a really big conflagration, it increases the likelihood of very extreme fire behavior. So that's one of the reasons why climate change is affecting wildfire. And the other two, and this is a little bit underappreciated, is the cycling between wet and dry is in some ways, in a warming climate, the worst climate for wildfire. There's actually paleoclimate evidence, plus a lot of anecdotal contemporary evidence suggesting this, and it's kind of intuitive if you think about it. If it just got perpetually hotter and drier everywhere, well, initially you'd see a big spike in fire activity, and eventually it would level off or even start to decrease as you essentially burned everything there was to burn, and it was too dry for it to grow back. But that's actually not what we see in a lot of places. What we see, and this is especially true in California, we had 2 historically severe droughts in the 2010s, and then we had a historically wet 2-year period that we're just finishing up now. What this means is that we had a lot of fire activity, a lot of fire burn areas, a lot of vegetation that turned into smoke, a lot of biomass that turned into smoke, but then we had a wet and relatively cooler period, and a lot of that vegetation is growing back. So in some ways, the worst climate for wildfire is one that gets hotter and hotter but alternates between extremely dry and extremely wet conditions, because you get these periods of extreme fire activity and then you pause and regrow a lot of that vegetation when it gets wet, and then you burn it all again when it gets dry. And in this way, you're constantly burning the vegetation and then seeing a lot of biomass recovery, regrowth, and then burning it again. And so there is evidence, and there's actually peer-reviewed research on this, suggesting that the constraints on future fire expansion in a warming climate that we used to think would be the case, because essentially you'd burn a lot of the burnable material and a lot of it wouldn't return quickly enough, is probably not the case. You might not be seeing the same vegetation regrow. So of course we're not seeing mature forests regrow in these high intensity burn environments over the course of 2 to 5 years. But what we are seeing is very dense grass and brush, and in some cases uniform small tree saplings. So say waist to knee to waist height saplings. It's not going to burn and behave the same as a mature forest fire, but actually in some ways it's easier to get pretty high intensity fires in very dense brushy environments with a lot of vegetation of uniform age and heights. So the more we see that across the landscape, we're seeing fires that are in a lot of cases reburning just a few years after the previous fires went through. And it's often not the same vegetation type, but it's plenty of vegetation for contiguous and sometimes pretty high intensity fires. And so in that way, my sort of hypothesis that is supported by an increasing amount of research is that the worst climate for wildfire is one that gets a lot hotter, as ours is, and alternates between extremely wet and extremely dry conditions for the reasons I just described. And there is a lot of evidence that that is likely where we're headed in the West, rather than an environment where it just gets perpetually drier all the time. We're more likely to see one that alternates between increasingly whiplashy wet and dry extremes while it gets hotter. And that is a pretty volatile climate for wildfire. All right, continuing. Yeah, some folks are remarking on the app watch duty. I am generally not a fan of apps, private apps for receiving critical emergency information. Although on the other hand, there still doesn't appear to be a better solution from the public sector, and so I have very mixed feelings about proprietary apps being a primary mode of information dissemination. On the other hand, I think Watch Duty is pretty good. I've been following it. I actually don't have it on my phone. I have a hard time physically using smartphones for apps. I actually mainly engage on social media via computer. It's really just quite difficult for me to manipulate the smaller screens, so I don't like things, and I have a hard time. I think this is actually a broader accessibility issue, a topic for another day. But there is, I believe now, a web interface for Watch Duty that's pretty good, and I have had it up in a tab in the background following some of these fires, because unfortunately Twitter or X isn't what it used to be in terms of information. It's actually not the first place that some of this late-breaking information often shows up, although it's still useful in other ways. So, by the way, social media-wise, you can see I'm still, of course, active on Twitter, or X as it's now called, but I'm also continuing to scale up on Blue Sky, and I'm on Mastodon. I now cross-post anything that I'm putting out into the universe directly, gets simultaneously posted via the Fedica. Ironically, it's an app, although it's, again, one I can access via a computer, so I'm able to use it easily. Everything you see gets posted across Twitter, Blue Sky, and Mastodon, and soon to be, I think later this month, Threads as well. So I'm trying to do better at blasting the whole social media universe, depending on which platform you're on. You can follow me on Instagram, but I only created that account because I had to get a Threads account, and I only post cloud photos there. So if that's your thing, check it out. But just a reminder that I am overly accessible on the internet, and so I'm quite easy to find. All right, there's a few folks talking about questions regarding whether the Sonoma County fire, which would be the Point Fire, started in any way related to a prescribed burn. It is the case that there was prescribed burning going on different corners of the Lake Sonoma area in the days prior to the fire, but I think anything beyond that is at this point speculation. From my understanding, the prescribed burning was being done on the other side of the lake, and so my guess is it's likely that there's no connection, although I can't say that with certainty. That'll come out of the eventual investigation, I'm sure. The reality is that there's not zero risk from prescribed fires, but the question is relative to what, I think. What is the counterfactual? The counterfactual is a world where we don't conduct the prescribed burns and where we get the big, bad, destructive wildfires instead. So, as I mentioned, we're not at peak seasonal burning conditions. This point fire is not behaving as extremely as it almost certainly would be under more typical September, October conditions. So regardless of what the ignition source was, it's important to recognize that, there is no zero risk solution, and there's also no zero fire solution. You're either going to see these fires as prescribed burns early in the season, usually, or as uncontrolled wildfires late in the season. And that does mean every once in a while there are going to be prescribed burns that escape bounds. Now, in a lot of cases, when prescribed burns do escape, they still don't really cause harm. So sometimes people get really concerned when a prescribed fire goes out of the original prescription boundary. And in a lot of cases, you'll get a slap over, that's what they called when it goes outside of the lines, a couple hundred acres, maybe a few thousand acres. But if it's just really doing more treatments in untreated areas without burning any structures or harming people, I think it's debatable whether that's really a major concern. Now, of course, it is a concern if that prescribed fire escape goes on to destroy structures or threaten life, which in the case of some rarefied selection of prescribed fire escapes in recent years has occurred. This is not unheard of, and there have been some pretty high-profile fires that have caused significant destruction that were the result of prescribed fire escapes. But keep in mind how rare that is relative to wildfires every year throughout the West that cause major destruction and loss of life in some cases. So I think we have to be thinking about what is the alternative, because the alternative is not that we never see any fire anywhere, period. The alternative is, in a lot of cases, it's these landscapes burning under more controlled, lower intensity settings for the most part, in prescribed fires or controlled burns, or in much less controlled settings and usually under much worse conditions at some other point in time when fire crews are not prepared for it, not set up to deal with it, and have to respond in an emergent fashion. So I have no insight into what the cause of this particular fire was. I think a lot of folks are assuming it was a prescribed fire escape without a lot of evidence. There were some prescribed fires going on in the days leading up to it in the general area, but I'm not aware of any prescribed fire that actually was occurring near the point of ignition. And, one thing to realize is that we do prescribe fires in landscapes that need them. Usually that means landscapes that don't have a recent fire history. And so perhaps it's not surprising that in some area immediately adjacent to a prescribed fire treatment zone, we saw pretty aggressive initial burning conditions because it hasn't been treated yet. And there is risk to humans and property in the area because it's a classic WUI or wildland urban interface zone. There's homes interspersed in pretty densely vegetated environment with some complex topography and a complex road network. So it's a classic WUI environment, a lot of ignition sources and a lot of potential assets at risk if you get a fire. So, it's a tricky environment, but I'm not going to speculate any further on that particular ignition because we don't know. There's no official information on that at this point. There is a comment that the central and northern Cascades up into British Columbia are very concerning from a snow water equivalent perspective. This is true. There's an extreme deficit of seasonal snowpack this spring and early summer up there, and so depending on what happens, this could be a problem later in fire season up there. The wild card is you do sometimes get meaningful summer and early autumn precipitation up there, so there's more of a potential for the weather to short circuit that. If it's hot, dry, and windy, it's going to be off to the races. But at least up there is the potential for it to be not hot, dry, and windy for late summer into autumn. So I'll keep my fingers crossed for some summer or early autumn rain up in BC and the Pacific Northwest. That's going to be a lot less likely though in California and most of the interior West. So as I think the northwestern U.S. and BC usually is operating under a different set of conditions than the rest of the West. I think that's fair to say. All right, let's see here. Do wildfires cause wind? I always notice that when the fires burn, the wind gets stronger. Well, this is an interesting question because the first order effect is that fires usually get bigger and spread faster when it is windy, ambiently, and that is not caused by the fire. So it's chicken or egg, correlation versus causation. On the other hand, it gets complicated because fires do generate their own winds, especially when they become sufficiently large or intense. Even a small-scale grass fire can create little circulations of wind on the small scale. But if you get a huge conflagration, thinking about some of the enormous multi-month burning fires we've seen in California in the West in recent years, those can develop what are effectively their own mesoscale weather systems, including thunderstorms and strong inflow and low and high pressure systems, even things like tornadic-like activity with those pyro vortices. So I mean, yes, fires can generate their own wind. In fact, they always do. Even if you have a campfire, if you were to measure small scale of vortices at really high resolution using advanced instrumentation, you'd be able to see the eddies that are generated by it. The larger the fire, the more likely it is to happen. So right now, we don't really have fires that are probably generating major changes in wind conditions. They just aren't big and bad enough at this point. So yesterday, for example, the point fire, that was pretty much all ambient wind. It was just a windy day, and people well outside the fire zone would attest to that. So the answer is, to a first order, no. It's the winds that cause the fires to get big and spread fast. But once the fires get big enough and spread fast enough, they actually can start to generate their own winds. So that is a classic example of a self-reinforcing or vicious cycle or positive feedback, as it's called. All right. Jen asks, I think there was an earlier question about centigrade versus Celsius. To my knowledge, they are completely interchangeable terms for referring to the centigrade temperature system. Often the system of measurement is often referred to as centigrade, and the actual temperature values themselves are in degrees Celsius. So Celsius is a unit of measure of temperature, and centigrade refers to the use of degrees Celsius. There is probably some inter-regional or inter-country difference in the use of that term. The U.S. is one of only a couple of, well, essentially the U.S. is one of the only countries in the world that uses the Fahrenheit system for most purposes. In science, the centigrade system, or an absolute unit of measure known as the temperature in Kelvin, which is even more complicated because those are not, the correct use is not degrees Kelvin, but the Kelvin system has the same size of unit as Celsius. So 1 degree Celsius is equivalent to 1 Kelvin, but there is a major offset where, of course, Kelvin is used to describe temperatures relative to absolute zero. So 0 Kelvin is the coldest possible temperature where there's no vibrational energy of molecules. So there's a 273 degree offset between 0 Kelvin and 0 centigrade. So the freezing point of water is 273 degree, even see there, even I go, 273 Kelvin, which is equivalent to 32 degrees Fahrenheit, making all of this very unnecessarily complicated. In science, usually we use centigrade or Kelvin, depending on the context. In colloquial weather and climate conversations in the US, we use the Fahrenheit system, and it means that climate scientists and weather scientists often have to toggle back and forth mentally between these two systems in the US. In the rest of the world, that mental math is unnecessary because everything is in Celsius. But here, to do public communication, especially to a primarily US audience, you got to do the mental math, Celsius, Fahrenheit. The usual way to think about it is 1 degree Celsius is equivalent to 1.8 degrees Fahrenheit. So it's not quite 2, but it is significantly different. And I think for whatever reason, intuitively, before I really got into the public communication of this and was constantly doing the mental math, for some reason I thought that the difference was smaller than that. But there is a pretty big difference in the gradation between degrees centigrade and degrees Fahrenheit. There is both the offset, where 0 centigrade is the freezing point and 32 Fahrenheit is the freezing point, but there's also the fact that the actual units of measure cover different increments of temperature. So the conversion value is 1.8. So you multiply degrees Celsius by 1.8 to get degrees Fahrenheit. All right, well, I think this has been an interesting conversation today. As usual, this will be available after YouTube renders it, which is usually pretty quickly. If you missed any part of it, go back and take a look. Just wanted to, again, thank folks for subscribing. That, I think, is one really helpful thing you can do if you haven't done so already. And sharing this channel. I really am, as I said, YouTube is kind of a unique platform, and I'm going to try hard to continue to expand the audience in the coming months and years, because frankly it is one of the best ways to have long-form conversations that I don't necessarily need to prepare greatly for. I can hop on and just have these real-time conversations whenever we need to. I'm liking that format. Other people seem to like that format. It's a great way to do these sort of pseudo press conference type situations where journalists can chime in and use the audio and the video for whatever purpose they need. So I'm liking it, but I would like to expand the channel. So I can certainly use your help in doing that in the months to come. So with that, thank you, and I will talk to all of you next time.